Welcome back. Now that we're drawing debug spheres, we can visualize locations in our world, which is great. Now, another useful tool is the debug line. Let's see how that works. We're going to go back to BP item, and we're going to first see how the blueprint node works for drawing debug lines. So I'm going to drag off of begin play and search for draw debug line. Let's get that node. Now, draw debug line requires a start and an end location for the line, just like a vector is defined by its start and end location. Now, we can start this line at the actor location for our item. So I'm going to get a getActorLocation node and plug that straight into the line start. But for the line end, I'd like to draw this line in the direction of our actor's forward vector. And we can get our actor's forward vector with the blueprint function getActorForwardVector. So getActorForwardVector returns a vector just like getActorLocation. But remember, we mentioned in the vectors section of this course that an object's location in the world can be represented by a vector, and that's the vector from the origin to the object's location. But the forward vector simply contains information pertaining to the actor's forward vector direction, and this is a normalized vector. So remember when we talked about normalized vectors, they have a length of 1. And I'd like to remind you that if we take a vector and we add another vector, then the result is the vector from the start of the first vector to the endpoint of the second vector. So in this diagram, if v1 is the position vector of our actor from the origin to its location, then if we add another vector, such as the forward vector, then the result is the vector from the origin to the tip of that point. So that's what we're going to do. We're going to add the actor forward vector to the actor's location vector. Now we can add two vectors together in blueprints, and it's as easy as dragging off of one vector using the plus key and getting an add node. So add is going to add these two, and as we've seen in the math section, adding two vectors together uses component-wise addition. So this node will return the vector that's the result of adding the x, y, and z components component-wise of these two vectors. So let's plug that into the line end, and we'll see what happens. Now I'd like to change the line color. I'm going to put a 1 for the red component of the color and click OK. So now we have a red debug line. Now for duration, I'm going to set this to 60 seconds and leave the thickness at 0. So now that we have a debug line that will start at the actor's location and end at the actor's location plus the forward vector, we should see a line from the actor's location to the point in space straight out in the direction of the forward vector. So let's go ahead and hit play, and let's see what this looks like. Now it's kind of hard to see, but if we go really close to the sphere, we'll see that line. It's really short. In fact, its length is 1. And in Unreal Engine, units are in centimeters by default. So we're looking at a line with a length of 1 centimeter. And it starts at the actor's location, and it goes outward in the actor's forward direction by a length of 1. Now that's kind of hard to see. So what we can do is take that forward vector and scale it up. We can multiply it, in a sense, multiply its x, y, and z components by a value to make it longer. So we do that by dragging off of the forward vector and using the asterisk, which will pull up the multiply node. And if we get that, we can multiply x, y, and z all by some value. I'd like to multiply x, y, and z each by 100. And now if I plug this into the add node, we're now adding a longer vector to the actor location. Now our end point will be outward in the forward direction of the actor by 100 units, 100 centimeters, so basically 1 meter. Now if we press play, now we can see that our debug line is a lot longer. It's 100 times longer. We scaled it by 100. So this shows us the forward direction of our actor. So this is great. Debug lines are really useful for depicting the direction of specific vectors. In our case, we're drawing the forward vector scaled by 100, and by adding it to the actor location, we're essentially placing this vector's start point at the actor's location. And that's why we can draw the vector like this. Now, this is great. We can do this in Blueprints now, but I'd like to do this from C++. So I'm going to go ahead and delete those nodes and hop back into Visual Studio. Now, here in item.cpp, since we've included draw debug helpers here, we can draw a debug line. Now, we've got lots of test code that we've added just to see how these functions work, but now I think we don't really need some of this stuff. I'm going to leave this world here as we're going to use it in a second, but I'm going to remove these lines of code from begin play, and down here in tick, I'm going to remove these lines as well, so that way we're not spamming the output log unnecessarily. All right, so now that we've cleaned things up, we're in begin play, and I have world. I'm going to keep that here, and I'm going to check if world is valid. And inside of my if check, let's draw a debug line. Now, draw debug helpers.h contains a function called draw debug line, and it works just like the blueprint node. Here in C++, though, it needs the world. That's why we kept that around. So let's pass in world for the first input. And next, notice it needs a line start and a line end. Now, we've called getActorLocation down here and stored it in our location vector. But that vector doesn't exist up here. The flow of execution of the code goes from top to bottom, right? So it's not going to get to this local vector variable before we call draw debug line here. But what we can do is declare this variable up here before we try to use it. So I'm going to highlight it and drag it up to just under our world here. And now it's defined, and we can pass it in right here. Now we need our line end. And I'd like to use the same logic we used in Blueprints, namely take our location and add the forward vector scaled by 100. And I'm going to do that just above our draw debug line function call. I'm going to make a new f vector here. And I'm going to call this forward and initialize it by using the function getActorForwardVector. So as we see, it has the same name in C++ as it does in Blueprints. That's not always the case, but for lots of functions, the function name in C++ is the same as it is in Blueprints, which makes it really useful. So we have our forward vector, right? And we want to add that to location. And the f vector type has overloaded the plus sign operator. So we can take location plus forward. Now, of course, forward is only a unit vector. It has a length of 1, so what we can do is multiply forward by 100, and I'm going to use 100.f to specify that this is a float value. So this quantity here, forward times 100, is the forward vector scaled up from a unit vector to a vector of 100 units long. And we're adding this to location, so we're doing the same thing we did in Blueprints. Notice how in C++ things look a little bit neater and more organized? That's just a benefit of using C++ instead of Blueprints. So let's add a comma so we can see the next required input, and that's the color. We're going to use fcolor red. And for B persistent lines, we can pass in true just to make sure that our line never goes away. So now we're doing this here in C++, but those lines were a little bit thin, so I'm going to add a comma just so I can get to the thickness input parameter and change that. So after B persistent lines, it's asking for a lifetime. But because we're using persistent lines, a lifetime doesn't have any meaning. That's why its default value is -1. And we can use -1.f since it wouldn't make sense to put 30 seconds or 60 seconds. If B persistent lines is true, we'll have the line drawn for the duration of the game. Now, depth priority has to do with whether or not this line is drawn on top of other lines or behind it. Now, it doesn't matter in our case. We really don't care if we're drawing lines on top of each other. And the type of this input is uint8, which is an 8-bit unsigned integer. We can simply pass a 0 for that to give it a depth priority of 0. And the lower the value, the higher the priority. So it'll be drawn on top of any other lines. Now for the thickness, I'm going to pass in 1.f. That way, we won't have lines of 0 thickness, we'll have lines of one thickness, which is a little bit thicker. So now that we're drawing a debug line, let's see how this works. I'm going to go ahead and save and hop back into the editor and hot reload. All right, so we finished. We can close live coding and hit play. And now take a look. We have thicker lines. And we're drawing this from C++, which is great. So now that we know how to do this from C++, notice that just like drawing debug spheres, this is kind of a lot of code to have to deal with. So it would be nice if we made a little macro just like draw sphere, only we did this for drawing a debug line. So I'd like to do that. I'm going to hop back into /h where we can define another macro. So let's go ahead and define this macro. So I'm going to say #define, and I'm going to call this one draw_line. Now, draw line is going to need more than one input because a line requires a start location and an end location. So let's add two inputs to this one. The first called start location and the second called end location. And just like draw sphere, we're going to check if getWorld. That way we don't execute anything after this if getWorld is a null pointer. And then we'll call draw debug line. Now draw debug line needs the world, so we're going to pass in getWorld, just like we did with draw debug sphere. And next we need our line start and our line end. So we have start location and end location. We'll pass those in. So first start location, followed by end location. Now for the color, and I'm just going to use red for this. So fcolor red. And for B persistent lines, we'll go ahead and use true. And just like we did when we called this function in item, I'm going to use a lifetime of -1.f to satisfy that input, and 0 for the depth priority, and for the line thickness, we'll use 1.f. And we'll add our semicolon there. And of course, this needs to be a comma there. Otherwise, I would get an error. So now we have a handy macro called drawLine. So back in item.cpp, just after we call drawSphere down here, I'm going to call drawLine and pass in location followed by this quantity here, location plus forward times 100. We'll pass that right there. And now we don't need these lines of code here. Now, before I remove them, there is one line that we're using, and that's forward. So what I'd like to do is move this out of the if check before I delete these. So I used Control X to cut it, and just under location, I pasted it here. And now I can remove these lines of code. Okay, so now our code looks a lot cleaner, a lot more manageable. Let's go ahead and save this. And back in the editor, we'll go ahead and hot reload. And now we can press play, and we see that we have our lines here. So this is great. Awesome. So now that we know how to draw debug lines, we can visualize things like the direction of a vector, and we now have a handy macro that we can use to save us some typing as long as we want a line of thickness 1 that's red and doesn't have a lifetime, so it'll stick around for the duration of the program. Excellent job. I'll see you in the next lecture.